All right. Hi, everyone. I hope you all had the chance to get a little coffee. I'm going to be talking about large language models today. And, well, as you probably know, the field of AI is currently advancing very fast. So there's new models being released almost daily. There's major breakthroughs almost every week. And like everyone is talking about how this affects us as humans, what does it mean for our future? And at least for me, this sometimes feels like very overwhelming. So in this talk, I want to focus on how we as web developers can make use of large language models to build cool features, to enhance our existing applications, and yeah, just put it into practice, right? So I want to start with a quick show of hands. Who of you has already used ChatGPT? That's everyone, perfect. So who of you has already built something with the OpenAI API? That's a few, very cool. Who of you has already used LangChain? Not that many, perfect. Has any one of you already like fine-tuned their own models? A few, okay, that's perfect. So this talk is going to be like an introduction talk. For those of you who already know everything, yeah, you probably won't learn that much new things. So who am I? I'm an engineer at the startup called Sutro, where we are using AI to enable people to build web and mobile applications without code. I'm also the co-founder of a company called Living Room Events. I've been in web development for quite some time now, and I live in Switzerland. So if you want to connect with me, feel free to do so on X or on LinkedIn. Now, before I get started with the cool stuff, let's quickly check out the architecture that makes large language models possible. So in the past, I used to give like a version of this talk together with my wife, who has like a very theoretical background in computer science and mathematics and AI. And she would do like this introduction into the transformers architecture. I'm just going to do like a very brief overview, but I won't be able to like answer many questions about the theory itself. So if we take a look at the timeline of natural language processing, then we can see that humans very early on, like already in the 1950s, tried to make use and try to like understand how languages are built with generative grammar. There was like kind of an experiment that they thought that language can be generated by a finite set of rules, which we now know is doesn't really work that way. Then in the 1960s, a few researchers at MIT realized ELIZA. ELIZA was like a very first model which used pattern matching to assist psychotherapists with their work. Then in the 80s, we had like the first expert systems. For example, mycin, which would identify bacteria that caused like several infections, and it used to recommend antibiotics, and with the dosage adjusted for the patient's body weight. And then, yeah, we had like various breakthroughs in the 90s where we had those neural networks, and then in the 2000s with language modeling, and then in the 2010s where like lots of things happened. But I would say the most important research paper to come out in the last few years is probably Attention is All You Need. It was released in 2017 by a team of Google researchers. And it described this transformer architecture, which forms the basis for all of large language models today. So here's a brief overview over the transformer architecture. It's a type of neural network which is primarily used in natural language processing, and it consists of an encoder, which handles like the inputs to the model, and of a decoder, which handles the outputs of the model. And the core innovation in transformer models is the attention mechanism, which enables it to focus on different parts of the input data and create a better understanding of text. So it can like relate words, like how they stand next to each other in a sentence, and better understand what they mean. Also, it enables us to like do parallel processing, and it can process entire sequences of data in parallel, and thus speeding up training and inference itself. Transformers can be used for language translation, text generation, content summarization, and many more text-based tasks, basically. Now, when we think of large language models, large usually refers to like with how much data they've been trained on. And they are being measured in like the amount of parameters they contain. And the first bigger models were like BERT, which was released by Google, had 340 million parameters. But GPT-3 had 175 billion parameters, so a really large model. And then with the GPT-4, they didn't tell us how many parameters it has exactly, but it was estimated to be around 1.8 trillion parameters. So those models are quite large. And yeah, a parameter basically refers to a weight inside the neural net. So this is just one of the connections that it formed. And I think in general, we can say that the more connections a model has, the better its like understanding is. Although we have to say that bigger is not always better, because there are now smaller models coming out as well, which perform significantly better than larger models. So when it comes to large language models, there are a few concerns and limitations too. I think like the most important one would probably be hallucinations. And this is just like how large language models work. They will not answer your question. They will just try to predict like the next few words of the text, right? And they will do so based on the training data that they were trained on. But if a model doesn't know about a specific concept, then it doesn't know that it doesn't know about that, and it will just try to make up an answer. It cannot tell you that it has no knowledge of this, it will just make up an answer. Also, there's a limited context length with those large language models, meaning that if you have like a chat interactions, you go back and forth, because it always has to parse like the whole history. At one point, it reaches its context length, its maximum context length, and then it cannot work anymore. So we have to work around that. Also, of course, there's like the environmental impact, because those models take up huge amounts of resources to train and to run. And then there are some ethical considerations as well, such as if the input data had biases in there, those biases will be present in the text that it generates too. Plus, yeah, there's obviously certain dangers for abuse of those systems as well. If you think about scams, about deepfakes, all of those things. But let's try to put those models into practice now for us. Now, in this talk, I'm going to be using a framework called LangChain. And LangChain is a framework to develop LLM-powered applications, and it follows a component structure to abstract away certain tools and providers. And like nowadays, most of programming in AI and machine learning happens in Python. But luckily for us, LangChain has a JavaScript library as well, so we as web developers can easily put this into practice and build cool features for our web applications. So LangChain consists of a few different modules. We have like the model I/O, which are just like interfaces to communicate with different large language models. We have a module called data connection, which is like a set of interfaces to deal with like external data. We have chains, like various amounts of chains, who are predefined sequences of interactions. Then we have agents, which allow us to define tools to be used by a language model. We have a memory to persist like conversation state, also between different runs of a chain. And callbacks basically just lets us log and stream all of the different steps inside a chain. But let's get started with a very simple example with the model I/O. And the use case for that could be, for example, something like this. On GitHub, if you create a new repository, you haven't entered a repository name yet, then it will just suggest one to you. It's usually like 2 words, and they're joined together by a dash. And that's something that we could easily build with an LLM. So how would we do that? So first of all, we have to create an instance of an AI model. We're going to use the GPT-4 model here, the chat model. And then basically we just create one message, human message in this case, and we say for a new Git repository, suggest a name to use. It should consist of 2 lowercase words joined together by a dash. The words don't have to make sense together. And then we just say chat.predict messages, and that's it. I'm quickly going to show how it could look like. I say generate sunset porridge, moonhopper, chicken velocity. Yeah, we could use those for a. We could definitely use those for a Git repository. That's it. So very simple, right? Let's make it a bit more interesting. Let's use prompt templates. Use case for that could be something like this, for example. That's a screenshot from a tool called Word AI. In here, basically, it just takes your text and it makes it sound much better. How can we use that? Well, basically like this. Once again, we create our chat model. And then instead to directly write the prompt, we will write the prompt template. It looks a bit like a JavaScript template string, right? So we can use the sentence as a variable and say, rewrite the following sentence. Make it sound like it was written by a professional copywriter. And then if the user entered something, then we can just say prompt.format, and then we do predict message once again. Quickly going to show how that works. Prompt format just replaces our so we pass the sentence in, and it replaces like the variable that we defined in the template string. All right, here I can say, yesterday I arrived in Lithuania, and it was called, but the conference I'm visiting is very nice. Yeah, it says, upon my arrival in Lithuania yesterday, I was greeted by a brisk chill in the air. However, the conference that I'm currently attending has proven to be quite delightful. That's very nice. That's much better than what I wrote. I could use that for my tweets. Yeah, let's talk about how we can teach our model new information. So the problem with large language models is that they have been trained on like a set of data. And yeah, for example, they had the GPT-4 has like a knowledge cutoff date in the end of like 2021, or I think like April now with the newer models. So they wouldn't know anything about what's happened in between this time, right? And if we want to teach new information to a large language model, there's basically two ways we can do this. So first of all, we can use fine-tuning, or we could use a technique called RAG, retrieval-augmented generation. So fine-tuning in general, I would say, is more used if you want to teach a behavior to a large language model. And RAG is rather if you wanted to use like ad hoc knowledge retrieval about like very up-to-date data, like internal data as well. And yeah, like the fine-tuning is, I would say, for more capable and bigger models, usually not really needed because they are very good at one and few-shot learning, meaning that you give like 1 or 2 or 3 examples, and it will learn it very quickly. Yeah, if you're going to use that internally, you could also like do a combination of the both, like to fine-tune it on a corpus of your own data, so it kind of has the concept of what you are like working on, and then do like RAG for specific knowledge retrieval. The next example I'm going to show is very simple. It's if we have an article somewhere, then we want to be able to chat with this article and ask questions about the article. The use case for this, I don't know, could just be didn't have time, article was too long, or it could be like asking some follow-up questions as well. It could be a Chrome extension, for example, whatsoever. Here's how that could look like. We create a GPT-4 model once again. Then, like this time, we are keeping track of all the messages we are sending and receiving from the model. We initialize it with like one system message, which uses a prompt template once again, and it says, you are a helpful assistant that answers questions about the following excerpt from a website title. Then there's the title, and then is the content. And after that, the user can just ask questions, and it will answer as best as it can. Let's check this out. So here's an article from OpenAI, and as you can see, that's from the releases last week, and it's way too long to read. So I pasted in here. Load. And then because I'm very lazy and don't want to read the whole article, I can just say, give me a one-word summary for the article. Updates. Wow, yeah. Of course. What kind of updates? Now the answer is not streaming now. That's because it so it takes a bit longer to appear. No, it just reads it once. Yeah. And then it tells me everything about the updates there, and I can ask more questions about like the new pricing and stuff and everything. Yeah. So that was obviously like a very simple example. This doesn't really scale if our information is longer than just one blog article, right? So if we have like a large corpus of knowledge, if we have like a knowledge system somewhere, then we're going to have to use a tool called vector databases. And vector databases are like the AI native way to store text or information in a database, basically. Now, for this example, we're going to build something about like ask the documentation. There's actually a few services out there already which do something like this. For example, LangChain itself uses a tool called, or a service called Mendable, which does exactly that, right? You can plug it into your own existing documentation, and instead of just searching through the documentation, you can ask it questions. Now, for the next example, we're going to use a database called ChromaDB. ChromaDB is like a very simple to use vector database. And in our vector database, basically, we have our documents, and those documents get translated into embeddings as well. Embeddings are basically just vectors, so an array of numbers. And to create those vectors, we need an embedding model. We're just going to be working with OpenAI's text embedding model because it's very simple to use and very cheap, but there are many, many others out there as well. So first of all, we have to get all of our data into the vector database. Now, for this example, I'm going to be working with the documentation of the Nuxt framework. Why? Because I think it's just a very good framework. Here's how we could prepare the data. So I made like a local copy with all the markdown files, and then I'm processing them file by file. First of all, I'm like parsing the front matter. That's like the metadata inside the markdown file. I'm going to use that as metadata. Then I'm going to use the content. And because those pages can be quite long, and it would be like, yeah, we don't want to include all of them in our prompt. We split them a bit more. There's actually this helper tool called recursive character text splitter included in LangChain already, which we're going to make use of. Now we're going to tell it that we're going to be parsing markdown, and if we set the chunk size large enough, then it will just split by titles basically, which is very nice. And then, yeah, we can use the splitter to create a few documents. For all the documents, we save like the metadata, and we generate a new unique ID. And now that we've done this, we can create like a connection to the ChromaDB. We're going to use the OpenAI embedding function, and we create a new collection, and then just add all of our documents to the collection. I feel like this syntax is a bit weird because it wants us to like separately pass in the IDs and the metadata and the documents. So to me, that feels like a bit counterintuitive, but anyway, you will get around it. So what we want to happen now, if a user asks a question, first of all, we're going to take the user's question. We are going to create an embedding for this. And with this, we are going to retrieve first all of what we think could be relevant documents. So we're going to do like the similarity search through our vector database. We're going to take the 10 first hits, and we are preparing a new prompt with the user question, as well as all of those text excerpts. And then we send this to the large language model and tell it like, this is the context to use. Only use this to answer the question. Don't make up any new answers. So how could we use this in our application? Well, we're going to create our model again. Then we are making a connection to the vector star. We're going to use the vector star as a retriever. Then we have to create like this prompt template, which is going to be like, use the following pieces of context to answer the question at the end. If you don't know the answer, just say that you don't know. Don't try to make up an answer. That's very, very important. Otherwise, you will just get random answers, and you cannot be sure if it's true or not. Then we pass in the context, chat history, the question, and then in the end, yeah, we are waiting for a helpful answer. We're going to use like a runnable sequence. This is like a new kind of thing in LangChain, quite a recent addition actually. Yeah, in there we're just going to give all the inputs, the question, the history, the context, and then we give the initial question prompt, the model, and then the output parser, but that's all included in LangChain already. And then in here, we're going to use the stream. So we want the streaming response. We want to see it in real time. And yeah, let's try this out now. I can say, how can I create a dynamic route and now it should be streaming. Oh yeah, had a little hiccup there. And then so what it did first, basically, it took my question, it searched through the vector database for like all the relevant articles, took those and sent them to the OpenAI API, basically, which was instructed then to create its answer based on those articles. Now it's generating this this answer for me. I can ask follow-up questions as well, because I'm always passing in like the history. How can I use those parameters in my component? I feel like it's a bit slow with its answers just today. Usually it's quicker. But so that's very cool, I think, because now we can ask it about like a very about like something the model itself didn't really have knowledge of before. It is very up-to-date information. We can ask it follow-up questions. We see the answer streaming in real time. So I think this is very cool. Yes, here is actually the correct answer how we could use this. So that's very nice. So so far, we've only been using the OpenAI API. We've been using the GPT-4 model. Why? Because it's very easy to use, because it's very capable. But it's not the only model out there. There are open models as well. And there's actually many reasons why you should be using open models. So first of all, there's no vendor lock-in. With OpenAI, it's just always, it's this American company. And yeah, you probably don't really want to send all of your data to this company and be too dependent on them. Open models can also run on-premise. They can run on your own infrastructure structure inside your own network. So that really helps if you have like some privacy concerns with your own data. It will always stay inside of your own network. It can be more cost efficient. Then you always have like those fine-tuning capabilities. You can fine-tune it as you want. And that could be interesting as well. They are usually uncensored, or there are uncensored models out there. Because with GPT, usually what OpenAI is doing, they are like building new safeguards in there. They are not allowing it to answer certain questions, and you don't have that with open models, basically. So there are many, many, many open models out there. I think one of the most important ones right now is Llama 2, which was released by the Meta team, which they are using internally as well. It comes in like 3 different sizes. It comes in a 7B model, which is very small, and a 13B, and then in a 70B. We can even use those models to run locally, or especially locally on this computer right now. There are different ways to do that, but I'm using an application called Ollama, which I think is very cool. You can use it to run other open models as well, not just Llama. And yeah, let's try to use Llama 2 for the use case we just had. Now, the cool thing about LangChain is that like switching out the model becomes very simple. Which is say the model is now going to be Ollama. It has like this connection because if I start Ollama on my computer, it runs this little API server, and then we specify the model. I'm going to use the medium-sized one. Well, the 70B model is very capable, but I just don't have the resources to run it on my small computer. So let's try out how Llama 2 performs. Okay, we ask it the same question. Oh, what happened? I ask it, how can I create dynamic routes? Now, it might be a bit slower than GPT-4, but remember that it's all working on this very, very small laptop right here. And you will see that this model is much smaller than GPT-4, but it's still able to answer questions like this. And if you do like some fine-tuning as well, then it becomes very, very capable as well. So yeah, it could answer the question, which is very nice. Okay. Let's get to the next topic, which is agents. Now, agents, I think, are like the most exciting part about large language models right now, because we can give tools to a model, and we also enable it to do like some intermediate steps, and not just like, it's not just input-output, but it's we enabled it to do like a few steps until it knows the answer that we're looking for, and then gets back to us with a definitive answer. Now, before I get too deep into this topic, I also have to mention that just last week, OpenAI presented their Assistance API, which kind of does something similar. You can also define tools in there. It's very simple, actually. You can plug in your own knowledge. Yeah, it looks like a really cool API, to be honest. But here's why I personally wouldn't use it just yet. So there you definitely have the vendor lock-in. You cannot just switch to anything else because they have like a very specific API. Also, there's like very limited control over how the whole knowledge retrieval process works. I think OpenAI has like lots of experience doing that with ChatGPT and so on, but you kind of have to trust them to do that right. So for now, I'm going to show you how to do that with LangChain. And the example for that is going to be we're building an application Copilot. Maybe you know a Copilot from GitHub, for example, where you can like ask questions about your own code, ask it to make edits to your own code. Well, I have developed like a very, very simple application. It's a to-do application. And I want to build a Copilot for this app. So how do we create the new agents? It's actually not that complicated with LangChain. We just do initialize agent executor with options. Then we're going to pass it a list of tools. We have to specify a model. We're going to use GPT-4. And then we have to specify the agent type. Like LangChain itself already defines various kinds of agents, but OpenAI has like this model, this GPT-4 model, which was like very fine-tuned for exactly this use case. So we're going to use this one. Now, with large language models, one thing is that they cannot make calculations, right? They only make like predictions over text. They have no concept over how math works, basically. So one of the simplest things we can do is we give it a calculator. This is actually a built-in tool by LangChain already. So you can always give it this tool, and it can use it. And then we could like ask it questions, math questions, and it will just refer to this tool to get its answer. But for our application, we're going to need a set of different tools, actually a set of 3 tools. The first one is we want a tool to list all of our to-dos. It's very simple. The name is list to-dos. We have to give a description, which is going to be passed to the language model. And this is see a list of all to-dos. The return value is going to be in JSON format. For every to-do, there is a text and a done field that indicates if the item was already done. And then if it's being called, then we just return a list of all our to-dos in the application, right? Then we have a tool to create a new to-do, where we say the parameter needs to be a string with the text of the item, and then we're just going to add a new item to our list of to-dos. And there's also one to finish to-dos. So let's take a look at how this works. All right, I can like just create a few tasks. Give talk, party. That's my talks, and then I can ask it what are my to-dos for today. And yeah, here in the browser console, you can see it's doing like some steps in between. And then it says you have 2 tasks for today, give a talk, and then party. So I just remembered that I probably should meet a few new people as well. Please create a task. And it's created a task for us. Now I could also ask it, what order do I do my tasks for today in. Give talk first, yes, good. Then meet new people and then party. Yes, that sounds very good. That sounds very good. But now I can say I'm almost done with giving my talk. Please complete the item. Oh. We'll see if this works. No, it didn't. It didn't actually work. I'll try it again. Yeah, didn't work. Sorry. It worked before. So I think this is very cool. I think we could take this a step further anyway. So I had this maybe stupid idea of like creating WebDev GPT, meaning that I gave it some tools to be able to read its own source code and make edits as well. And so you could ask it to make like changes on the application it itself is running in. The application is running in Nuxt with the dev server, so we have hot module replacement on, so we should be able to see the changes in real time. Yeah, what could possibly go wrong? Let's try it out. Well, you can say on the current page, make the background of the generate button yellow. Let's try it out. I have updated the background color. Now it's disabled, so we cannot see. Oh, it's yellow. Nice. Change the font to Comic Sans. We'll see if it works. Not sure. No, not really. Almost though. Almost. It's kind of a weird demo to give because like it's very non-deterministic. I have no idea if it works this time, but it has worked in the past. You will have to trust me though. The question is, how does it know if it should make changes?
Yes, or for example, how does it? Yeah, thank you. So the question is, how does it understand whether it has to make really some changes, like to add a new item to the to-do list or to change the color of the button, versus just print the output as a text in that box?
Yeah. So the model we're using, the OpenAI functions model, was really fine-tuned for exactly this use case. So in the system prompt, we also told it that it's like a helpful assistant, and it can assist with to-dos, but also it can make applications, it can make changes to the application itself. We gave it the tools, and by itself, basically, it knows if it should use those tools or not. That's what it was fine-tuned on, right? In the code? Yes, I can actually do that. I'm actually done anyway, so I'm at the question stage. So let's. 1 second. I'm gonna have to find it first. I'm gonna change how I'm sharing the screen. Okay, can you see that? It's probably a bit too small, right? So in here, basically, that's how I initialized it. I said, you are a helpful assistant that can help with using a to-do application, but you can also assist to make changes in web application. The application is built using Knox3 and Tailwind CSS. Only ask the user for help if you already tried the tools. The user is currently on page example 5, and the global styles are defined in assets index CSS. And then basically I gave it just a set of tools. I gave it a set of tools. There's one tool to list like all the files. There's one to view a certain file. There's one to make edits. And then we have the tools for the to-dos as well.
And does it scope to the current folder, or I mean, you can type like format C, you cannot do that?
No, because I didn't give it a tool to do that. No, we implement the tools ourselves.